Do you know that you have probably already experienced augmented reality? Have you played Pokemon Go to catch wild Pokemons on a walk? Or maybe you have used face filters on Snapchat? If the answer is yes, then you have experienced augmented reality as part of the application. But if you don't know what augmented reality is, don't worry. For those who have never heard about augmented reality, this is the standard definition of augmented reality. Augmented reality is the technology that overlays computer-generated images on top of the physical environment. Perhaps you have also heard about virtual reality and are unsure how these concepts differ. Both augmented reality and virtual reality use computer-generated images, but virtual reality builds a completely digital world to replace the real world. In other words, if virtual reality replaces the physical environment with the artificial one, augmented reality enhances the view of the physical environment using computer-generated images. Today, there is a lot of hype around augmented reality. However, the term was coined by Thomas Caudell almost 30 years ago. In fact, the concept itself is even older than that. The first augmented reality application was developed in 1968 by Ivan Sutherland, who is also regarded as the founding father of augmented reality. But back then, the augmented reality equipment was heavy, bulky, and had very limited computing capacity. However, the emergence of small but powerful devices such as smartphones, tablets, and Microsoft HoloLens has made augmented reality much more feasible for our daily life activities. Augmented reality applications can be found in many domains, for example, entertainment, education, and even automotive. Despite the wide adoption of augmented reality in some domains, there are other domains where the use of augmented reality is still limited, even though the apparent benefits that augmented reality could provide to those domains. For example, industrial vehicles have been slow to adopt and implement augmented reality. Industrial vehicles, or also known as off-highway vehicles, are vehicles that are designed for specific tasks, such as lifting, demolishing, and even harvesting. Why could it be important to use augmented reality in industrial vehicles? One of the main reasons is to improve safety. Here is the situation. Operating an industrial vehicle is difficult since the operator is not only required to drive the machine, but also to perform heavy-duty operations and monitor the vehicle's surroundings. This complex and constant multitasking can overload an operator and make it difficult for even an experienced operator to remain fully aware of the surroundings. This can potentially lead to accidents, as operating an industrial vehicles is a dangerous job both for the operator and site workers. A study in 2018 also showed that 46% of accidents involving industrial vehicles were caused by the operators. So, what can augmented reality do to help solving this serious issue? Augmented reality can be used to present critical information near the operator's line of sight. Thus, they will be able to absorb and react to the information more easily. This will enable the operators to mitigate upcoming hazards accordingly. Therefore, the risk of accidents can be reduced as well. If the benefit of using augmented reality could be so important, then what is currently preventing augmented reality from being used in industrial vehicles? In order to answer that question, we first need to understand four basic technological components of augmented reality: displays, tracking sensors, input devices, and processors. Displays are the device where computer-generated images are presented. The examples are smartphone screens, headsets, head-up displays, and even projectors. Next, tracking is the process of determining where computer-generated images should be displayed with respect to the physical environment. This is done using sensors. The third component is input devices, which allow users to interact and manipulate computer-generated images. This can be in the form of touchscreens, keyboards, joysticks, and even through body gesture. Lastly, processors represent the brain of an augmented reality application, where the information from input devices and tracking sensors are processed and then presented to the user through the display. In industrial vehicles, the main problem is related to the display. Let's have a look at the two of the most interesting choices for implementing augmented reality in industrial vehicles: transparent displays and head-mounted displays. The transparent display would be a good option here, since the information can be presented directly in the vehicle's windscreen. However, most of the available transparent displays are limited in size, while industrial vehicles usually have large and wide windscreens, and the operator is also required to look to all directions. The head-mounted display is another option, but current head-mounted displays are still bulky in size and have limited computing capacity. Other limitations, including battery life, operator's comfort, and certification requirements, made head-mounted displays in their current form less suitable for industrial vehicles. In addition, both transparent displays and head-mounted displays are also strongly influenced by external factors, such as brightness, which could deteriorate the quality of the presented information. However, as the technology advances, we believe that applications using augmented reality will soon become a reality in industrial vehicles. Thanks for watching. This video has been made as a part of Science Labs within the ImmerSAFE project.